All right. Well, if you're watching this at the beginning of the broadcast, usually takes a few minutes before students start jumping on. So I'm going to email out a time that says watch the video after this moment. Anyways, so let me go ahead and do that, and I will join you later. Hi, Louisa. I don't know if you can hear me. Just kind of hanging out for a few minutes, and then I'll get started. If you have any specific questions, you can type it, and then I'll just answer yours first, I guess. And I don't think your mic is shut off, so you can actually talk if you want. Or not. That's terrible. You can check. I would check your computer settings. Mic doesn't work. Okay. Well, clearly I can't help you on that end. But I guess I can talk. Anything off the top of your head I can answer real quick, or you just would like to watch the show? Turning a base 10 number in a base. Do you have a specific number you would like to convert, or I've got something on the practice test. Let's see, the practice test one. I think the practice test one had converted to base 7. Oh, we lost Monique. I'm probably thinking her name was supposed to be Monica. Oh, never mind, she's back in. Louisa, did you just want me to do the one off the practice test? Okay. Let me go to the practice test one, and if it's not the one you're thinking of, then that's okay. At least you got to see something live, I guess. So I'm going to share my screen, and we'll see how this goes. Gets weird and creepy. Okay, so this is the one that I was thinking you were referencing. Either that, or you want to go. Oh, okay. Let's start with number 1. Maybe number 1 is what you were talking about. Okay, so let me pull up something I can type in. Okay, so the way we want to think about this one is there is some number times. I guess I'm going to do this backwards. It's 8 to the 0 power times something. Oops. And we're going to fill in that blank. We're going to fill that number in with a blank for now. And then it's 8 to the first power times something. And then it's 8 to the second power times something. So we're essentially trying to fill in the blanks here with different powers of 8. And I got one more, because I know this one happens to goes out to x cubed, or 8 cubed. Okay, so what I need to do then is I need to figure out how many times can I fit 8 cubed into 35456. So that 6 is 8 to the 0. 5 goes 8 to the first. The 4 happens to go 8 squared. And then the 3 goes with 8 cubed. And so that's what we're going to type into our calculator. And I'm going to, forgot to load up my calculator, so let me go do that real quick. And the question I keep getting is, can I use a calculator? And the answer is yes. You definitely need to use a calculator. I'm testing more on setting up skills than anything else. So anyways, 3 times 8 cubed plus, oops, not that plus, plus 4 times 8 squared plus 5 times 8, and then plus 6. And so this number ends up being 1,838. Oops. Okay, there's that. Yay. Okay. Is that what you were thinking about, Louisa? And it was actually number 2. Okay, let me go back again. Let me try this again. I think if we want to conduct a little brief experiment, I think if I have my name highlighted, I don't think anyone else's screen will take over. So if you guys, those that have mics, if you want to try to activate them and try talking, we could try that. And if it ends up kidnapping the screen and so you can't see what I'm doing, then I'll mute everybody and we'll shut that down. But we can try that experiment if you want. Otherwise, I'm going to go to number 2. Okay. Number 2 has nothing to do with base 10. This is preceding and succeeding. Okay. So the way I suggested that we handle something like this is we just start counting in base 7 and see if we notice any sort of interesting pattern. So if I'm going to count in base 7, I would start with 0 and then 1 and then 2 and then 3, 4, 5, 6. And because it's in base 7, I don't get to 7, but instead I go to the next row and it's 1, 0, and 1, 1, and 1, 2, and 1, 3, 1, 4, 1, 5. And I get to 1, 6, and it's not 17, but we carry another place value in the next row, and so that would be 2, 0, and then 2, 1, and then 2, 2. Okay. Now, the way I suggested in, I think someone emailed me this question a lot, and I made a quick tutorial on that and sent it out. The reason why I'm suggesting you write out the pattern is take a look at what you're being asked. You've got 1, 2, 0 to base 7. Well, the 1's position has a 0 in it, so look down here. What do we notice after we have a 0? What's after it? Well, after it we always have a 1, 1 or a 2, 1. So if I want this number and I want the number that's after it, I'm going to go here. Let me insert this. Oops. Okay, so the number after it should have a 1, 2, 1, and it should be base 7. So the number after it would be, or succeeding it, would be 1, 1, 2, 1, 7. And before it, so if we look again at our patterns, now quit being difficult. Okay, so if we look at the number before it, so here I got a 2, 0, then I have a 1, 6. Here I have a 1, 0, then I have a 6. So clearly, the number before this one has to, instead of the 0 position, has to have a 6. And notice the other thing is that when it says 2, then it said 1. If it said 1, then it had nothing. So that 2 right there has got to go down 1 unit. So the number will look like 1, 1, 6, all in base 7. I don't know why that's being difficult. Okay. Okay. Louisa, you're being difficult. One more try. Here we go again. I'm going to go do number 3 now. That's okay. We'll figure this out. Unfortunately, I have to, yeah, like I said, oh wow, this thing is really being, okay, here we go. All right, number 3, here we go. This is the one you wanted. Okay. Convert 1,256 to base 7. Okay, so first thing I want to know is what's the biggest power of 7 I can fit inside 1,256. So if I go 7 squared, obviously that's 40. Sorry, let's try that again. That didn't come out well at all. 7 squared is 49. 7 cubed is 343. 7 to the 4th is 2,401. Okay, well 7 to the 4th is clearly too big. So I'm going to look at 343 then. How many 343s can I fit into 1256? So I'm just going to take that number, 1256 divided by 343. And it goes in there 3 times, and there's a remainder bit. So I'm going to figure out what that remainder is by taking the 1256 minus 3 times 343. And I get 227. Okay, so let me come over here. So what I know so far is I know it's 3 times 7 to the 3rd power. Okay, plus, come back over here. All right, now I'm down to 227, so I want to think about 7 squared. How many 7 squareds can fit into 227? Well, 7 squared is 49. So I'm going to take the 227 divided by 49, and it goes in there 4 times. What's the remainder? So 227 minus 4 times 49. And I should get something smaller than 49, which I do. So this would be 4 times 7 squared. Okay, plus, go back here. Now I want to know how many 7s fit into 31. 7 times 4 is 28. So I know I can fit 4 7s in there. Alright, so that's 4 times 7 plus, and then how many are left over? 3. So that's 3 times 7 to the 0 power. Okay. So if I collect up all of the numbers in front, all the coefficients, then 1,256 in base 7 would be 3,443 base 7. Okay. Did I finally get to the question you wanted? All right, yay! And then if anyone else, Dana or Christine or Monica, if you guys have a question, you can type it in. Or if you want to activate your mic and just tell me what it is, that's fine. Otherwise, I'm just going to stare at the screen. So someone asks something. And I can just go through the review sheet or the practice test if you want. Okay, hold on. Monica said, in question 9 is the intersection of set or the product method. Okay, so let me jump to number 9 and see what that is referencing. Alright, number 9. Okay. Well, it actually, I mean, the question says find using the intersection of sets. So what I want to do is I want to first figure out what's the prime factorization of 60 and 252. So what numbers break up into 60? So I'll come over here. And let's see, I know clearly that 2 goes in there. Once and twice. So that's 2 times 2 times 3 times 5. Okay. And then 252. So 252. I know 2 goes in there. So once and twice. And then I run out of 2's. So it's 2 times 2. And then I can see that 3 goes in. So I divide by 3. And another 3 goes in. So 3 times 3 times 3 times 3 times 7 is what it looked like. Okay, so what I'm going to do then, I'm going to do, this is going to be the lamest set ever. All right, what do they have in common? I see they have a 2 and a 2 and a 3. So 2 times 2 times 3. And then this, no, well, hold on. I'm trying to be creative on, this is so much easier when I can write on paper. Okay, so this is the things that break up to 60. This is both, and this is 252. Okay, so I can see that they both have a 2 sets of 2's. They both have 2 sets of 3's. 60's got another factor of 5, and 252 has got a 3 times 7. Okay, so what I'm doing here, if I take 5 times 2 times 2 times 3, I get 60. And if I take 2 times 2 times 3 times 3 times 7, I get 252. Okay? So the GCD is the both part, so that's the 2 times 2 times 3, and the LCM is just collecting up all of it. So 2 times 2 times 3 times 3 times 5 times 7. So I just collect up all of these numbers that would generate the LCM. All right, let me make sure I got Monica's question. Okay, so Monica, did that answer your question? Yes, okay. I love it when people figure out icons that I have yet to play with. So, all right, awesome. All right, so Christine asked for number 4. So let me go do that. And I can hear my family in the background, so I might have to go unlock the door real quick. But we'll see. We'll have fun with this. Let's see. So number 4, going back. Okay. So number 4 says A has 4 elements, B has 15. The union of the bunch has 10. How many are in the intersection? Okay, so let me go back to that table trick. Let's see if that works. So this would be everything in A. This would be everything in both. And this would be everything in B. And I know that A happens to have 4 in it. When I did this live, I think I realized, oh wait, you can't have 9 things in both. That's just silly, because then A wouldn't exist. So So I think I went back and I changed this, but I didn't change it for the paper. So let's make A be something a little bigger. So here, I'm just going to cheat. Because I can do that. I can just retype this. Assuming I can retype this. It doesn't act silly on me. Oh, the swirl of waiting. I think I broke the internet. Alright, what are you doing? I just clicked on an icon. How can you be stalling this long? Alright, let me wait a few seconds and see what's going on here. You go brush your teeth.
I don't eat my vitamins.
Okay, still go brush your teeth.
Okay.
Okay. Yes, they can hear you.
Right now?
Right now.
They're gonna laugh.
They are laughing. They're laughing because Daddy's computer's being silly. Oh, look at that. I broke the internet. Alright, hold on. Let me figure out what's going on.